Hello everyone, I am Pooja Bhattare.
Myself, Vinay Deepak Nave.
I'm Rajesh Vilas Nape.
And I'm Prathamesh Kasid. Now we are talking about air-breathing engines. This type of engines use oxygen from the atmosphere for fuel burning and produce thrust. And this type of engine is more efficient than a rocket engine and also play a important role in aviation industries.
Now let's see what are air breathing engines. Air breathing engines use oxygen from atmosphere for combustion. They are lighter and more efficient than rocket engine because they do not carry their own oxygen. Let's see construction. This diagram shows the basic part of air breathing engines. First, air enters through the air intake. Then the compressor increases the air pressure. After that, fuel is added in combustion chamber. Then an air-fuel mixture is burned. The hot gases rotates the turbine, which derives the compressor. Finally, the gases exit through the exhaust nozzle, producing thrust. This engine is a turbojet engine. First air enters through the air intake, then blade is rotated. This is a compression blades. Compression blades increase air pressure. This is a stator and this is a rotary blade. Combination of two.
So now we see a combustion chamber. This is the cantilever section. The air is come front of the engines and goes from the diverter and divert the air and rotate. Now the fuel is injected from these holes and the mixture of fuel and air is mixed from inside and ready for the burning.
So after the combustion chamber, here is the presence of the stator. It makes the streamline from the fuel which is burnt. The burnt fuel goes in the nozzle part. The stator is make the streamline. Then we go to the rotor. Here are the presence rotor. You can see it. They make a path and divert the air which is coming from the front inlet. Then here is the process has been completed. Then so afterburner. Afterburner is that which air is not compressed in the combustion chamber. It compressed it and increase the efficiency of the engine. And then here the portion you can see in the green highlighted, that is the nozzle. Thank you.
So as my team members explained, so here we can see some connections which we will be using in real life aircraft applications. So the main part so if anyone can copy this engine or they can make it look like another engine. Here we have this in nose section we can see the small holes. So it is a hole the engine is connected to throughout the shaft and so it is having the key mechanism, so no one can dismantle it, so no one can copy the mechanism or the engineering of the engine.
So from the explanation of Pooja, we got an idea about the air breathing engines. So the basic principle of the air breathing engines and the gas turbines are based on the Newton's third law. It is that every action has equal and opposite reaction. Means the engines are based on horizontally. The last section of the engines is the nozzle. From the nozzle, thrust is exerted. Due to that, engine goes forward. Then it is based on the Brayton cycle. That is the graph presence here. The Brayton cycle have the four main stages. First stage is adiabatic compression. From the here to here, there we see adiabatic compression. The here to here we see adiabatic compression. Here the pressure is increased. Inlet is present here. So air is coming inside the engine from to that. So then second to third there is the constant pressure and heat addition. there is a addition of fuel in second to third step. Then third step is adiabatic expansion. Here we see the expansion of the gases are the happen in the third to fourth step, and then moving to the last step and the fourth step, there is the concentration heat rejection. Means here is the cycle is completely done. So there is a temperature, pressure, and entropy are the main components in the Breton cycle we seen. Then moving to second slide. Here we can see the performance of the turbine variants. Like there are the three main types of turbine engines. First is turbojet engine, then turbofan engine, then turboprop engine. First we are moving to the turbojet engine. There is a working in the means high speed working of the jet engines are in turbojet engine. This type of engines are the old fashioned engines, and they are used in older means older age means past now that is not used. Then they have make more thrust, but they have high speed applications. They are efficient to supersonic and subsonic, and they but means disadvantages of that engine is they produced more noise than the speed. Then going to the turbofan engines are the mainly based on the fan presence on their tip. There is a huge fan is placed that intake the air and move forwards around the passing of the air. It helps to compress the air and build expansion, and then the working is done by the turbofan. Then that advantages is saving fuel, that is fuel efficient, but noise is minimum in turbofan than turbojet. Then so moving to the turboprop engine, there is a main thing is propeller meant 90% of the thrust in that engine. Then for turbojet engine, it is used in older jet flights, and turbofan engine it is used in high speed but long distance flights, and turboprop engine is used in means the regional flights, and there is a speed limit for that. 450 mph is the speed limit for the turboprop engines, and they are the cost effective. So there we use for the efficiency for the cost.
So after talking about the jet engines, we will discuss about the compressors. So compressors mainly have two types: centrifugal compressor and axial compressor. So in centrifugal, it turns the air outward using the centrifugal force, like how we have spiral like structure, or like a spinning we can say. It is used in small engines and helicopters. So it is tough, simple, and creates lot of pressure in just one spin, like how we have in diesel engine, like or petrol engine in two stroke or four stroke. We can here we like comparing, we can have here it is there we have cycle, here we can compare it to spin. So now we will talk about the axial compressor. It's a series of spinning fans which we call rotors, and some stationary fans which we call stators. So rotors are like the rotating part, and stators are like stators. So it is used in big jets. It allows for a massive amount of air to flow through the which it needs high speed and high power. So it we can see it in image, the axial compressor here, and we can see the difference between the axial and centrifugal in the image. We'll be comparing the variants, like how we discuss all the models or variants we can say, like we can see the in further video. So in engine type, first we have a turboprop, which has a speed range of Mach 0. Means 0 to 0.6, so which is it has a method of propeller plus compressor. So its best feature is to have highest fuel efficiency at low speed. So it can be used in mostly the commercial we can say. Then we have turbofan, which is having the Mach number around 0.7 to 0.9, which has the compression method of fan plus axial compressor. So like we will talk about this feature is like it is quite an efficient for long distance travel. So we can use this type of engines in cargo aircraft. So now we will talk about the turbojet, which has the Mach number around 1 to 3. So its compression method is either axial or centrifugal compression. It depends upon the manufacturer. And its best feature is the high power for supersonic combat or flight. So it can be used in superjet. So now after turbojet we have ramjet, which have Mach number around 3 to 6. So its compression method is ram pressure, like vehicle speed, which means there is somehow difference of speed range in ramjet and scramjet. We will firstly talk about the features. In ramjet we have simplicity, like works where fan would melt, like at high temperature it couldn't resist. So in scramjet it has hypersonic speed, so fastest air breathing in it, like comparatively to ramjet, scramjet can be better.
So now we air breathing engines are very important in a modern aviation. They use atmospheric air to burn fuel and produce thrust, which makes them lighter and more efficient than a rocket engines. Different type of engines are used for different type of speed range and applications. Thank you.